You've definitely seen this chart before, the periodic table. It's got to be one of the most iconic images in all of science, right? It's this perfect, elegant map of, well, everything, all matter. It feels so fundamental, so perfect. It's like it was just handed down, a basic law of nature. But you know, the story of how we actually got it is a wild ride. It's a chaotic tale of false starts, dead ends, and a mystery that took centuries to piece together.
And that really brings us to the core mystery of this whole story. Was this incredible map of the universe invented in some single flash of genius? Or was it something else? Was it an inevitable pattern just sitting there in nature, slowly being discovered, waiting for someone to finally find that last crucial piece of the puzzle?
To get to the bottom of this, we've got to rewind, way back. Picture the 18th century, a time of pure, absolute chemical chaos. Seriously, there was no shared language for what things were made of. It was a world dominated by theories that honestly sound a lot more like alchemy than what we think of as science today. And the biggest, most powerful idea of them all was a theory about fire.
Yeah, it was called the phlogiston theory. And, the logic kind of made sense at first. When you burn a log, it turns into ash, and it gets lighter. So something must be escaping, right? They called that something phlogiston. It was supposed to be this essential spirit of fire. And for decades, it was the central idea in all of chemistry.
But see, this simple idea had one massive, glaring flaw. A problem that chemists just couldn't ignore anymore. When you take a piece of metal and burn it, something really weird happens. It doesn't get lighter. No, it gets heavier. Now wait a minute. If burning is all about releasing this phlogiston stuff, how in the world could the leftovers weigh more? The whole theory was starting to fall apart. So to solve this mystery, chemists didn't just need better ideas, they needed better eyes. They needed some revolutionary new tools that could reveal parts of the world that literally no one had ever seen before.
And this is where the dominoes really start to fall. First, an inventor named Stephen Hales creates this thing called the pneumatic trough. It's a super clever device that could capture gases. And this one invention changed everything. It lets scientists like Antoine Lavoisier finally isolate and study different kinds of airs, which led them straight to the discovery of oxygen. And with that, bam, the weight problem was solved. Burning wasn't about losing phlogiston, it was about gaining oxygen. Just like that, the old theory was dead.
With the phlogiston theory out of the way, the pace of discovery just exploded. Around 1800, the first battery, the voltaic pile, let chemists just rip compounds apart with electricity, revealing a whole flood of new elements. Then came the spectroscope, which could identify an element just by its unique fingerprint of light. Suddenly, elements were being discovered left and right, and this created a brand new kind of chaos.
So you solve one problem, and you get a new one. With dozens of new elements identified, chemists were just drowning in data. They had all these puzzle pieces, but nobody had a clue how they were supposed to fit together. The chaos was back, just in a totally new form.
They knew that elements combined in fixed ratios, kind of like a recipe. But the problem was, nobody could agree on the ingredients. They were constantly arguing about the most basic facts, like how much an oxygen atom weighed, or even what the correct formula for water was. I mean, it was an absolute mess.
Just think about this for a second. In one chemistry textbook, for something as simple as acetic acid, that's basically vinegar, there were 19 different formulas being proposed. Not 2 or 3, 19. This quote just perfectly captures the state of chemistry back then. It was just total confusion. No standards, no agreement.
But here's the crazy part. The solution had actually been proposed decades earlier, all the way back in 1811, by a guy named Amadeo Avogadro. He made this brilliant distinction. Think of it like this. An atom is like a single Lego brick. But he realized when gases are floating around, those bricks often travel in pairs, clipped together as a molecule. This simple but totally crucial idea was the key to finally calculating the correct atomic weights.
So what was the problem? Well, his idea was just way ahead of its time. It was confusing, it wasn't explained very well, and for nearly half a century, 50 years, almost everyone just ignored it. The key to ending all that chaos was just sitting there, collecting dust, until 1860, when another chemist, Stanislaw Cannizzaro, championed the idea and finally got the scientific world on board.
And with that final piece finally in place, the stage was set. All the clues were now on the table, literally. The time was finally right for this hidden pattern in nature to reveal itself.
So by the 1860s, everything was ready to go. You had all the essential puzzle pieces. First, you had a modern definition of what an element actually was. Second, you had a critical mass of over 60 known elements to play with. And third,
And this was the game changer. You finally had a reliable, agreed-upon system for measuring their atomic weights. The stage was set.
And this is where the Russian chemist Dimitri Mendeleev walks onto the scene. He started arranging the elements by their atomic weight, and here's his moment of pure genius. When the pattern broke, he didn't try to force things to fit, no. Instead, he boldly left gaps in his table, and he claimed they were just placeholders for elements that hadn't been discovered yet. He even predicted what their properties would be.
And then came the moment of truth, the ultimate confirmation. In 1875, a new element, gallium, was discovered. Its properties were an almost perfect match for one of Mendeleev's predictions. Then, a few years later, germanium was discovered, and it fit another gap perfectly. This was it. This was the proof everyone needed.
You see, Mendeleev hadn't just made a tidy little chart, he had drawn a map of the entire material world. It didn't just show the known territories. It was so powerful it even marked, "Here be dragons," in the blank spaces, predicting the nature of elements we hadn't even found yet.
This whole journey was just a chain of cause and effect. As one writer put it, the discoveries were made in a necessary and inevitable order. And it's so true. The pneumatic trough had to come before oxygen. Oxygen had to come before we could ditch phlogiston. And accurate atomic weights absolutely had to come before the periodic table. It was an inevitable cascade of discovery.
So let's go back to our big question. Was the periodic table invented or discovered? Well, the answer seems pretty clear. It was discovered, piece by painstaking piece, by generations of scientists. Of course, Mendeleev was brilliant, but he was standing at the end of a very long road that others had built. One tool, one idea, and one discovery at a time.
And that leaves us with a pretty fascinating question to think about. When we look at the cutting edge of science today, things like AI or gene editing or quantum computing, what fundamental patterns are we just one tool or maybe one key insight away from revealing? What breakthroughs that are happening right now will seem just as logical and just as inevitable to the historians of tomorrow?